Hey everyone, welcome to Stuff I Found Interesting. Today's rabbit hole is exoplanets. Stuff in space has always been crazy. There's too much stuff out there and we know frighteningly little about it. As a part of learning more about space, humanity has naturally gravitated towards finding other planets out there. The goals are to find planets with life, find planets that could support humanity, and learn more about how planets are formed. In checking out what planets we have already identified, I've found an interesting gas giant and a rock world that are wild and thought I should share. Additionally, the James Webb Space Telescope just found its first exoplanet, so I added that one in here as a bonus. Now, what are exoplanets? They are planets that are found outside of our own solar system. Exoplanets can be made up of various forms of rock, like Earth, or different gases, like Jupiter. Due to the Kepler Space Telescope, NASA has found that there are more planets than stars in the Milky Way galaxy. Think about that. We can't even tell how many stars there are in the galaxy. Scientists argue that it could be as few as 100 billion, or as many as 400 billion. That's billion with a B. Regardless of how many actual stars there are, multiply that by a factor of at least 2, and you will get the absolute minimum number of celestial bodies we have floating around in our very own galaxy. If you want to further break your brain, we don't even have the instruments to accurately measure how many galaxies there are. Scientists also say that there are around 100 to 200 billion galaxies. The James Webb Space Telescope, JWST, is a part of that massive undertaking. I don't know about you, but this is a bit more than I can comprehend without some serious help. Here's a quick summary of the James Webb Space Telescope. It is most likely going to be the subject of an entire video later down the line. The James Webb Space Telescope is a space observatory that will be operated by NASA and the European Space Agency, ESA. It was launched on December 25th, 2021, and is the successor to the Hubble Space Telescope. The telescope consists of a 6.5 meter primary mirror, 4 science instruments, and a sun shield. It is designed to study a wide range of phenomena in the universe, including the formation of galaxies, stars, and planets, to better understand the history and evolution of the universe. It will also be used to search for exoplanets and to study the atmospheres of planets outside our solar system. JWST has been designed to observe infrared light and will be positioned in an orbit 1.5 million kilometers from Earth, which is further than the Hubble Space Telescope. This will allow the telescope to observe infrared light without the interference from Earth's atmosphere. The JWST is expected to revolutionize astronomy and help to answer some of the most pressing questions about the universe. Now, why is knowing about exoplanets important? Eventually, we wish to expand humanity beyond our solar system, and it would only be polite to check out the neighborhoods before we up and move. Getting as much information about the vast possibilities that space offers us allows us to make informed decisions on developmental paths for science and technology. Pushing further and further into the space program will force us to solve the problems that come with how inhospitable space is. As we develop new technology to explore space, those inventions will trickle down into the general population and improve the quality of life for everyone. On a more serious note, finding exoplanets allows us to understand the universe just that little bit more. We are able to infer a lot of information about how planets are formed, so we can test theories that have been around for a while. As we find more star systems with planets, we start to see patterns in how the fundamental laws of the universe, as we know them, work. If we have enough data points, we could find the series of events that took place to create life on Earth, and see if anywhere else in the observable universe has a similar set of circumstances. The law of large numbers tells us that on the scale of the universe, if it happened once, it likely happened many times. Now, how do we find exoplanets? There are a few methods that we use to find planets outside our solar system. The first is the radial velocity method. This method measures the gravitational influence of a planet on its star. When a planet orbits a star, the star is slightly tugged towards that planet due to the planet's gravitational pull. This causes the star to wobble slightly, and this movement can be detected using spectroscopy, which measures the Doppler shift of the star's light. By measuring the Doppler shift of the star's light over time, scientists can infer the presence of a planet orbiting the star. The second is transit method. This method looks for the dimming of a star's light caused by a planet passing in front of it. When a planet transits or crosses in front of its star from the perspective of the observer on Earth, it blocks a small fraction of the star's light. By measuring the amount of dimming and the duration of the transit, scientists can infer the size and orbit of a planet. The third is direct imaging. This method involves taking a direct photograph or spectroscopy measurement of an exoplanet. This is the most difficult method to use because exoplanets are very faint and are often lost in the glare of the star. However, it is the only method that can provide detailed information about the composition and atmosphere of a planet. The fourth method of finding exoplanets is called microlensing. This method looks for the gravitational influence of a planet on the light of a distant star. When a planet passes in front of a distant star, it bends the light of the star due to its gravitational field. By measuring the amount of bending, scientists can infer the mass and distance of the planet. The fifth method of finding exoplanets is called pulsar timing. This method looks for the gravitational influence of a planet on a pulsar, which is a neutron star that emits regular pulses of radio waves. When a planet orbits a pulsar, it causes the pulsar radio waves to arrive slightly earlier or later than expected. Due to the gravitational pull of the planet, by measuring these small deviations in the arrival time of the radio waves, scientists can infer the presence of a planet. Now, what are some interesting exoplanets? The first one that I came across is called WASP-17b. I was trying to see if it was common to have Jupiter-sized planets in other systems. It turns out that 17b is a gas giant similar to Jupiter, but was almost twice its size, 1.87 times Jupiter's radius. This extra size came at the expense of its overall mass, which is about 3/4 of Jupiter. On top of 17b being so much bigger than Jupiter, it is also 95% closer to its star than Earth is. Where Earth is 1 AU distance from the Sun, 17b is 0.0515 AU. That is so close that it takes less than 4 days to orbit its Sun. For reference, Mercury is 0.4 AU. 17b was found using the transit method that we covered before. After 17b, I started looking at a bunch of other exoplanets to see if this increase in size was common. The real reason was to see if we got the short end of the stick with our local resources. It turns out that while not common, it isn't unheard of to have other gas giants be this large. Most systems that have planets in them that we have found tend to follow the same rules, which is crazy to think that they also follow those same physics laws that we have figured out. However, there was another outlier that caught my eye. I wanted to see if there were any other rocky planets like Earth out there that broke the size scale. It turns out that there are some. The one that I'm highlighting goes by the sexy name TOI-849b. I'll just be calling it Rocky because that's much easier. Rocky is even closer to its star than 17b, at 98.4% closer than Earth, 0.016 AU. Obviously, since this is so close, it tends to get a bit hot at 2800 degrees Fahrenheit or 1500 degrees Celsius. Also, since Rocky is so close, it takes less than a single day to completely orbit its star. Rocky is exceptional due to its mass, being almost 40 times Earth. Usually when planets get this massive, they become gas giants just due to the incredible amount of gravity that its mass will generate. Researchers aren't quite sure what went wrong with its development, as this is an outlier that doesn't really fit with the rest of the planets that we have found so far. Their best guess is that there were a series of catastrophic events that stripped Rocky of its atmosphere, preventing its ability to trap all the gases to create a gas giant. Another alternative is that Rocky was too close to the star, so all the atmosphere was evaporated away by the intense radiation of the output of the star. The James Webb Space Telescope has made a remarkable discovery confirming the existence of an exoplanet for the first time. This distant world is known as LHS 475b. It's located 41 light years away in the Octans constellation, and it is almost identical in size to Earth. This opens up a world of possibilities for further research and exploration. The research team used JWST to analyze the planet across multiple wavelengths of light to see whether it has an atmosphere. The telescope's sensitivity picked up on a range of molecules that were present, and the researchers were able to rule out certain terrestrial-type atmospheres. However, more research needs to be done to confirm the presence of an actual atmosphere. JWST is the only telescope that has the capability to characterize the atmospheres of exoplanets that are the size of Earth. This is a major milestone for astronomy and space exploration, as the telescope can provide valuable insight into the makeup of these distant worlds. The planet is a few hundred degrees warmer than our planet and completes a single orbit around its red dwarf host star every 2 Earth days. This close proximity to the star could be conducive to the planet maintaining an atmosphere, making it potentially more like Venus than Earth. The researchers believe, their discovery will just be the first of many in the JWST's future, as the telescope is bringing us closer to a new understanding of Earth-like worlds outside the solar system. With the potential to explore the atmospheres of these distant exoplanets, the James Webb Space Telescope has opened a door to a wealth of opportunity for further study and exploration. By now, humanity has discovered thousands of planets within our local area of the Milky Way, with that number rising all the time. The launch of the James Webb Space Telescope has allowed us to see further into space than ever before. Finding out more about space, both in general and our local area of the Milky Way, can teach us so much about how the universe works. And we need to know how stuff works so that we can create things that take advantage of that knowledge to make everyone's lives easier. As we learn more, that knowledge is distributed around the world via the internet. That new information inspires people to pursue careers in science, technology, engineering, and math, which are critical fields for the future and will lead towards the betterment of all humanity. The vastness of the universe is an awe-inspiring reminder of how much there is to learn and discover. Exploring space encourages us to be curious and never stop learning. Thank you all for watching this video. I've had fun learning and creating it. Let me know if I missed anything or if you wish for me to dive deeper into any given topic. The gift of your time and attention means a great deal to me, as this is the most precious resource any of us have. It doesn't matter who you are, everyone gets 24 hours in a day. Thank you for spending a part of it with me.